Hi there. Thanks for joining us on Space Nuts Q&A. My name is Andrew Dunkley, your host. It's great to have your company. And we thank our audience for sending in questions. We got some new ones the other day, so we're going to try and knock off a few of those in this episode. Viano has got in touch with us this week. He's asking questions about planets and photographing planets and missions to distant planets that we might be able to take a look at. But will there be problems if we want to send back images? We've got a question from Brady. Could a moon have a moon? That's a good question. Let's look into that. And Scott is asking about the star system HDF 110067. I'm sure you know it well. We'll find out all about it this week on Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to tackle all of those questions with most insightful answers, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Hopefully this will be Q&A rather than Q and not A,
Yeah.
which is always the risk.
Yeah, it is a bit, but, even when we get questions we can't answer, which we've actually received while we've been talking today, we will chase them up if we can. So never be discouraged. We'd love to get your questions, and we'll tell you how to do that at the end. Let's go to our first question, Fred. And this one, as I said, comes from Viano.
Hi guys, Riano from Florence in Italy. So I have two questions for you. The first one is related to the Breakthrough project. You told us that you want to reach Proxima Centauri with a sort of solar sail at around 1/3 of the speed of light, which I think it means more or less 100 kilometers per second. I worked with industrial cameras and I know how difficult it is to find the right exposure time, configuration, the optical lenses, focus, and so on. And I was thinking that maybe it will not be possible to take a clear picture of a planet if we're moving so fast in front of it. What do you think about that? The second question is related to the planet's orbit. So can you please explain me what is that defines the distance between the planets and the sun? So for sure there must be a sort of gravity equilibrium, but I cannot understand why they are not in order considering their mass or their volume. So there must be something else. And so, guys, I started listening to you because I wanted to learn some English. I'm pretty sure my English is not so good or improved, but I started looking at the sky. I love the stars now, and I think it is great. So thank you, guys. Bye-bye.
Thanks, Viano. I'm a little bit disturbed that you think we're going to be helpful with your English, but no, I'm really pleased that you sent us a question. Your English is actually very good.
Very good indeed.
Yeah, we understood perfectly what you were asking us. But yeah, thanks for sending in a question. It's greatly appreciated. And having been in Florence fairly recently, what an amazing place. You live in a beautiful part of the world. I happened to be there at All Saints weekend, which is a 4-day public holiday, and there were thousands and thousands and thousands of people there. It was almost impossible to move through the city square and see all the sights. Just everyone flocked to Florence that weekend. Big religious holiday, but what an amazing place. Yes, and beautiful part of Italy too. It's just extraordinary around there. Now, he mentioned the Breakthrough project. This is the plan to send micro spacecraft on a flyby of Alpha Centauri, the planets of Alpha Centauri B, is it? And they won't be able to stop. I remember us talking about that. So let's just sort of review what Breakthrough is about and then try and answer Viano's questions as to whether or not we'd be able to send back a photo or two of any planets involved.
It is actually a great question, and I think there's quite a lot of subtlety to it. So it's a Breakthrough Starshot, and that project was initiated by Yuri Milner, Russian billionaire who set up the Breakthrough Foundation in order to study the possibilities of using light sails, laser-driven light sails, to accelerate a spacecraft which might only weigh less than a kilogram. It's tiny stuff we're talking about, to a speed which would allow you to reach Proxima Centauri, the nearest of the Alpha Centauri system, a red dwarf star, within a reasonable number of years. And so, if you accelerate it to a third of the speed of light, 100,000 kilometers per second, as Viano says, then you're probably going to take, allowing for acceleration and deceleration, you're probably going to take less than 20 years to get your 4 light years away. And then you're faced with the issue, and it probably wouldn't be just one spacecraft. I think it will be a little flotilla of sail-driven spacecraft.
Yeah.
Which would fly along the laser line, accelerated. I'm sorry. There's the people are complaining about our rooster, Andrew. They think he's a chook. They think he's a cockerel. But he's not. He's a dog with a stupid voice.
And he does that when someone turns up.
He does, or even when somebody turns up. He just does it because he
just does it occasionally.
I've counselled him.
It's the nature of the breed. Yes. It's the nature of little terriers, or little terrors, whichever way you want to look at it.
That's right. Anyway, you whiz through the Proxima Centauri system, and it does have planets at 100,000 kilometers per second. You've got cameras that are supposed to be able to photograph planets. You want to photograph them in enough detail that you can actually see what's going on their surface. Yeah. That is an incredibly difficult problem. The nearest thing I can draw a parallel to, which was very successful, was New Horizons flyby of the Pluto system back in 2015. Is that right? 14th of July, 2015, I think that was it.
Let me check.
Brains, yeah, you check that. And actually, I might have the 14 might be something else, because my recollection is that the flyby velocity...
The 14 was the 14th of July, 2015.
There you go. That's got it right.
Yeah.
Check the other figure for me, though, Andrew, because I think, if I remember rightly, the flyby velocity was 14 kilometers per second.
It's... I haven't got that, but I will look it up.
No, okay. Just to make sure. So, and that was an amazing feat of engineering.
23 kilometers per second.
Okay, 23. So I'm mixing up the 14 with the date. Yeah, 23 kilometers per second. Are you sure that was the flyby velocity? That sounds more like the maximum velocity.
Well, hang on. I'll keep looking. Hang on a second.
Yeah, I think it was the fastest spacecraft ever launched, because at one point in its trajectory, probably after
here it is. New Horizons flew within 12,500 kilometers of Pluto at a relative velocity of 11 kilometers per second.
11. Okay, that sounds more like it. Yes. 11 kilometers per second. So it's a very small percentage of 100,000 kilometers per second, which is what the flyby speed will be for any breakthrough starshot initiatives. But it was highly successful. What they had to do, because you can't control this in real time, Andrew, because you've got, I can't remember what the time delay was, but it was minutes out to get the signal out there. And this thing flashes by. So they had a pre-arranged sequence of shots, the camera angles to get not just Pluto as they flew by, but Pluto's moons, all of them, including the biggest one, Charon. They did fantastic planning and built into the engineering of this, so that when the spacecraft got within X thousand kilometers of Pluto, this sequence started and it was executed perfectly. It was just choreographed set of imagery. And of course, I guess we're all familiar with the dramatic pictures that were returned.
Amazing
Now-
pictures. 6 hours, the time delay.
6 hours, there you go. Yeah.
Mm.
So thank you. I'm glad you're there. It's a long time ago. What's that? It's 9 years ago since all this
Yeah,
was
it is.
happening, and I give talks on it. I talked about Pluto about 100 times, I think. So I knew the numbers, but it's receding into the past. Anyway, to the issue that Viano raises, we have a different set of circumstances here. We've got these tiny little machines which have cameras on board, pointing hopefully in the right direction. You've got a 4.5-year time lag back to Earth, so there's no chance whatsoever of pointing the thing. It has to all be done robotically, so you're going to have sensors on board that will look for the brightest object in the field of view and basically point your camera towards it. But at 100,000 kilometers per second, there are also what we call relativistic effects. The geometry of space changes. So you're not just taking, saying, well, we know where these things are, we can point the camera at them. You've got to take into account the fact that space is distorted by the relative velocity, 100,000 kilometers per second, third of the speed of light.
Are you space Sorry, that was me.
which will change the directions of the things that you're looking in. It basically squashes the stars forward in your field of view, that relativistic effect. So all those phenomena, and I think, if Viano's raising doubts about whether this is feasible, I think he's right on the money, because I think it is so difficult to do. We don't even know whether the technology would work to get us there in that length of time, but it's a very interesting problem, and it's one that needs to have interesting answers.
Yes, indeed. I mean, he brought into play other effects like the distance of the planet from the stars, exposure times. Just so many other factors that need to be.
Yeah.
And I'm sure the scientists involved would take that into account, but
Yes.
there's certain things they won't be able to control. And when you're talking robotics, once they're on their way, that's it. You're not really going to be able to do much once they get too far away to take those photographs and transmit them back. You're just going to sit and wait and hope and pray that it all works.
And then 4.5 years later, you get your pictures back.
Yeah, and it's just
If
a
you're
fuzzy
lucky.
blob. Yeah.
Yeah. The other bit of Viano's question was about the orbits of planets, and it's why are planets in a particular orbit? There's the orbit is basically dictated very much by the distance. The two go completely together. In fact, the mass of the object itself is of less importance. For example, on if you're in Earth orbit, if you're at 400 kilometers, you've got to have a certain velocity to stay in orbit, whether you're a CubeSat or whether you are the International Space Station, much more massive than a CubeSat. So it's all about the orbital velocity and the distance from the sun. That's what dictates basically where planets stay. They've obviously formed there at those distances. We think the gas giants are gas giants because they're beyond the frost line, so that they grew big as they accumulated ice. And that made them, gave them the possibility of accumulating still more material, the gas around them. Hope that answers the question, Viana.
Viano, thanks very much, and so good to hear from you, and hope all is well in Florence. This is Space Nuts, Andrew Dunkley with Professor Fred Watson.
Space Nuts.
Now, Fred, we've got a text question that's come in from Brady. Hello from the great state of Florida, with a great view of all the launches here. Oh, you lucky duck. I was wondering if a moon could have a moon. Also, would that be called a moon? Love listening to you all every week, Brady. Thanks, Brady. Very jealous of where you are. I'd love to be able to sit and watch a few launches from Florida. What a mesmerising place. I've been lucky enough to visit there and found it all very extraordinary. Could a moon have a moon, Fred?
just to a footnote to that, I'll be there in about 3 weeks, Andrew.
Yes, you will.
Cape Canaveral.
Yeah. Well, by the time
Anyway,
this episode's out, you're probably already
last
been
week.
there. Yeah.
But moon of a moon, yes, such an object will be defined as a sub-satellite. So satellites are moons. It's satellites, the technical term that we use. Nowadays, people think of them as artificial satellites, but actually the word means the satellite of a planet, something going around a planet. A sub-satellite would be something going around a satellite. And the answer is yes, it could. Theoretically, you could have a sub-satellite. You could have a moon of a moon. But the odds are that they're quite rare. And the reason for that is that we know of none in the solar system. Of all the 200 or 300 moons that we know in the solar system, I can't remember the exact number now, none of them have a sub-satellite. None of them have a moon. So that is probably because theory suggests that and this would depend on what the planet was like, the planet that these things are going around. It's the tidal effects of the planet that are probably what would disturb, or what has disturbed any possible sub-satellites in the solar system. So what I'm saying is, in the solar system at least, the reason why we don't find moons of moons is because of the gravitational pull of the planets themselves. These actually would make it unstable. So you lose the moon of the moon. The moon itself might stay there, but this other moon going around it might be too unstable in its orbit just because of the tidal effects. That's the gravitational pulling effects of the planet itself. But that might not always be the case. It's the case in the solar system, but it might not always be the case. And there is at least one basically one planet, which is Kepler 1625b, which could, in theory, have a satellite, and in theory could have a sub-satellite. So that's just because of the gravitational distribution between the parent star, which is Kepler 1625, and the planet Kepler 1625b. That's one suggestion. But as far as we know, there aren't any in the solar system.
Okay. So for it to happen, the circumstances have to be exactly right.
That's right. They have to be a bit special.
The answer to your question, Fred, 293 moons in our solar system.
Oh, there you go. 293. Thank you.
At last count.
Yeah.
Thanks, Brady. I like your name better. Moon. That works for me.
Moon's good.
Yes, it does. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
3, 2, 1.
Space Nuts.
Now we've got a question from Scott.
Hey, this is Scott from Oregon. I recently became aware of HD 110067 system because apparently it has 6 exoplanets that are orbiting in like a perfect mathematical arrangement or something. But my real question is really about it's a part of a triple star system. And at least according to the information I found, the companion planet it's actually a companion binary star system, is 13,400 astronomical units from the primary star. And I'm just kind of curious as why, when something is that far away, is it kind of considered still like a triple star system? I just assume that they, that seems like a really far distance for them to still be kind of considered together. So I'm just kind of curious about how they kind of categorize these things. Thanks.
Thank you, Scott. That is a great question. Triple star system, but he's questioning distance and whether or not it could actually be that. That's how far is too far for a binary / triple star system?
That's look, and again, this is a great question, and it's really all about gravitational, what we call gravitational binding. So that star HD 110067 is gravitationally bound to this spectroscopic binary system, which is called HD 110106. Now, you know, that 110067 is interesting because of these 6 planets, which are in a lovely orbital resonance with each other. It's at a distance of 105 light years. But Scott's question isn't really about the planet, the star and its planets. It's about this companion binary system. What do we mean by a spectroscopic binary system? A binary system is 2 stars orbiting around their common center of gravity, usually called the barycenter. If it's spectroscopic, it means we can't see them as 2 separate stars. We can see them as a single star in any telescope, but we know it's 2 stars because the spectroscope or the spectrograph reveals by the Doppler effect that there are 2 sets of barcodes which are moving relative to one another as the stars orbit each other. So it's by using the spectroscope that we know that there is a pair of stars there rather than just a single one. Whereas HD 110067 itself is said to be part of this as a triple star system. So, Scott quotes, and I haven't actually verified this, but I'm sure he's right, 13,400 astronomical units of separation between them. Now, that's about a quarter of a light year. A light year is about 63,300 astronomical units. Oh, what's an astronomical unit? Distance from the Earth to the Sun, 150 million kilometers. So an astronomical unit is a unit we use within the solar system. We tend to use light years beyond the solar system. But for a triple star system, that is quite a long way off, 13,400 astronomical units. As I said, it's roughly a quarter of a light year. I'm going to throw in a coincidence here, Andrew, that you probably don't know about, but the number of astronomical units in a light year is, as I said, about 63,300. Is very, very similar to the number of inches in a mile, which is about 63,300.
Oh, right. Wow.
It's a nice coincidence that we can't use anymore because we're all metric here in Australia.
Yeah, well,
anyway,
they can use it in America.
They can, yes. But so what defines it as these two, the binary and the star itself, HD 110067? What makes it a triple star system? It's because they're gravitationally bound. The movement of the two relative to each other tell you that they are in orbit around their common center of gravity. And so, once again, that's detected spectroscopically and probably actually also by the Gaia astrometry spacecraft, which can measure the positions of stars very, very accurately indeed. So I think that is why it's termed as triple system rather than just two stars that happen to be near each other. It's because they've got movements that suggest that they're gravitationally bound to each other.
They are dancing.
They're dancing. What a lovely way to put it, Andrew.
Yes. Yeah. Well, if they dance like me, one of them's going to fall over real quick.
Indeed.
So there you are, Scott. Hopefully that will appease you, at least answer your question. We got one without notice, and I know you love those, Fred. This comes from a Facebook listener, Dean. G'day, fellas. Question for you. How does Hubble maintain a steady image of targets while in orbit?
It's stabilized, and what stabilizes it are gyroscopes, which are an absolutely vital part of the mechanism that operates Hubble. And in fact, it's why Hubble's lifetime will eventually be limited, because the gyroscopes did fail. I think they need 3. I think they can just about manage with 2, but they need 3 to work properly. Back in the day, 2000, probably 2011-ish, thereabouts. trying to think when I think 2011 was when the last Hubble repair mission went up, and it was to repair or to replace gyroscopes. That was in the last year or so of the space shuttle, because the space shuttle was the only vehicle then available that could reach the orbit of the Hubble Space Telescope at 600 kilometers. So it's gyroscopes which have failed. They're still working pretty well as far as I know, but maybe again they will fail, and that will bring the mission to an end because you won't be able to point the telescope.
Yes, exactly. And that was 2023, I think, when, it was a while further back than that. I remember us talking about those gyro failures. It wasn't that long ago.
There might have been other ones.
Could have been.
Since that mission. Yeah.
I mean, Hubble's been up there at it for a very long time. Things don't last forever.
34 years.
Yeah, it's incredible, isn't it?
Yeah.
Of course, there are going to be new telescopes like James Webb in action, and the new one that ESA set up. And of course, we talk about one.
Nancy Grace Roman telescope.
Which is also going to be launched in a few years. So plenty more going up there to continue the work. But thanks for the question. Lovely to hear from you, Dean. And if you do have questions for us, please send them to us via our website, spacenutspodcast.com, spacenuts.io, and send it to us simply by clicking on the relative button. You can click on the AMA tab where you can send us audio or text questions, or on the right-hand side, there's this weird green button that says send us your questions. When you hover over it, it turns purple. Yeah, I don't know. But you can send us your question there. As long as you've got a device with a microphone, all good. And don't forget to tell us who you are and where you're from, and we'll do our best to give you an answer. Fred, that's the end of another episode. Thank you, sir.
Pleasure. Good questions there and great stuff. Keep them coming in, folks. It's great to hear.
Yeah. All right, Fred, catch you next week.
Thank you.
Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio who funneled through a couple of late questions that we managed to, we put one on the back burner and we tackled the other. And from me, Andrew Dunkley, thanks for joining us. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.